Welcome to the first installment of the Zero Hedge Advanced Nuclear Technology series. I'm your host, Erik Townsend. Many of you also know me as the host of Macro Voices, the free weekly podcast that targets pro-finance, family offices, and other sophisticated private investors. Nuclear energy offers the cleanest, safest, and most abundant energy source known to mankind. But savvy investors already know the caveat to that story. Nuclear energy suffers two serious problems that have made it a dubious investment. Despite all its merits, nuclear energy simply costs too much and takes too long to build. Well, guess what? It seems that my guests this evening didn't get the memo on that because they built their first nuclear reactor in 40 days and they turned it on for the first time on the 4th of July. It performed flawlessly and made history. Now, just a month earlier, back in May and the first few days of June, it had been more than 50 years since a new first of a kind nuclear reactor had been started at the Idaho National Laboratory. But my guest's reactor was not the first to break that record. Four separate companies have turned on first of a kind advanced nuclear reactors in the last month. That's the first time in the history of the world that four brand new reactor designs were started up for the first time in 1 month. And that's after more than a 50-year hiatus. To my thinking, that marked the dawn of the second nuclear age, and my guests are very much making history. So, without further ado, I want to introduce tonight's guests. They are the founders of Aalo Atomics, a company that fully intends to mass produce advanced nuclear reactors on high volume assembly lines. Full disclosure, yes, you better believe that I'm an investor in Aalo Atomics personally. In fact, it's my largest single stock holding. The CEO is Matt Loszak. Matt, welcome aboard and congratulations to you and your team for making history this past holiday weekend.
Awesome. Thank you so much for having us, Erik, and it's a pleasure to be here.
Yasir Arafat, no relation, I'm assuming, or maybe, is Aalo's co-founder and chief technology officer. Yasir, welcome aboard and congratulations to you as well. You guys really are making history.
Thank you, Erik. Thanks for having us. It's very exciting. We're excited to be here.
Before we go on, I'd like to announce our plans to launch the Zero Hedge Nuclear CTOs debate series. We're going to be inviting Yasir and the CTOs of several other advanced nuclear startups back for more advanced nuclear content. Specifically, we're going to break down all that technical jargon and explain what it means for investors. So when you hear that Aalo's building a uranium oxide fueled sodium reactor while other guys are building a HALEU triso fueled helium cooled reactor, you'll actually know what all that gobbledygook means and why it's so important for investors to understand, which I assure you it really is. So now let's dive into tonight's interview. Gentlemen, I want to start by giving our viewers some perspective on what just happened in Idaho last month. As of June 2nd, not a single new first-of-a-kind nuclear reactor had been started at INL in more than 50 years. Elvis Presley was still alive for the last startup, although I understand he didn't attend. What happened? Four new nuclear reactors were started in the last month. How did that come about? Why is it so significant to the future of nuclear energy? And what role did your company play in it?
So our company was started around 3 years ago. It was just me and Yasir around 2.5 years ago-ish. Now we're 200 people, and we were already well on our way into DOE authorization when the executive orders came out, which was last summer. But that basically started the kind of shot clock, and they introduced essentially 10 different companies, 11 if you double count Oklo's 2 projects, and said, hey guys, our order here, our executive order is for 3 of you to achieve criticality by July 4th of this year, which was this past Saturday. And we are very pleased to announce that we have achieved this executive order as of 12:20 a.m. On the Saturday morning, Friday night. So we cut it close, but we pulled it off. And we cut it close because we took on quite a bit of scope. We had a very large reactor. We built our own building. We'll get into those details. But it was an incredibly exciting process. And Yasser and I looked at each other when we achieved it, and we honestly cried because we'd had so much stress built up and so much tension in achieving this monumental milestone, given the scale and scope of what we took on. It was a huge celebration for the whole team when we achieved it. So it was the best 4th of July I think either of us have ever had.
And that was live streamed, and the replay of the live stream is available online. If you follow Aalo Atomics at Aalo Atomics on X, you'll find the replay link for the live stream of that whole criticality event. And criticality just refers to turning on a nuclear reactor and establishing a sustained nuclear chain reaction. Yasir, anything you want to add to what Matt said?
No, I think Matt covered the gist on it. There's a lot of folks that went a few weeks earlier before the July 4th timeline. So we were not early on that timeline. We were not late. I call this a JIT reactor, just in time. So we want to make nuclear predictable again. And so no way to make it more predictable than hit it exactly on the day when the deadline is.
Now, as I think about the nuclear power industry, I kind of think, the grid service for major electric utilities, they're really still focused on lightwater reactors, the old school, what's called Generation 3 technology. For the Generation 4 advanced reactors where you guys live, it seems to me there's 3 markets that have kind of established themselves. One is off the grid, what used to be the market that was dominated by diesel generator sets, these micro reactors that could be set up in the middle of nowhere in order to power a mining village or something. The next one is the military niche, the things that the Pentagon is willing to pay a Pentagon-sized budget for. The third one, because what these all share in common is somebody's got to be willing to pay up for the latest Generation 4 technology. The third one is data centers who urgently need more power than the grid can supply. Which one of those 3 niches do you guys fit into? Do you agree? I guess I should ask, first of all, do you agree that that's the way the market has kind of broken itself out? But where do you fit in, and what is the goal that you're trying to achieve in terms of what your company wants to deliver for mass-produced nuclear reactors?
Maybe I can kick this one off, and then Yasser will fill in the gaps here. So we like to think of it as you have these micro reactors, which are these kind of entire power plants in a box, right? So kind of the radiance of the world. And these are going after 1 megawatt kind of remote diesel military applications, like you said. And then on the way other side of the spectrum, you've got the gigawatt scale bespoke reactors that are kind of these giga projects. They take 10 years, massive construction projects that have more recently kind of, especially in the West, been difficult to build on schedule, on budget. And in our case, we're very much laser focused on building the ideal product for AI data centers. And those first 2 types of products that I mentioned there, neither of them is a good fit for data centers. The former is too small, too expensive. The latter is too large and too slow. It takes 5 or 10 years to build those larger plants, and data centers get built in 6 to 9 months. So that middle category that you were alluding to, where it's whether it's behind the meter, in front of the meter, what have you, it's kind of more about the size, the scalability, the supply chain, and matching that for data centers. So something that can be produced very quickly at a low enough LCOE with a strong enough supply chain to actually do it at real scale. And maybe Yasser can elaborate on how we're doing that, because that's really why I think we stand alone in terms of just how good our product market fit is for data centers.
Yeah, Eric, just to tie into that, oftentimes in nuclear, we see people design nuclear reactors and then figure out where exactly we can fit this solution to. When we started Aalo, obviously we wanted to solve some of the 2 of the biggest challenges in nuclear, speed and economics. But we wanted to make sure we're deliberate about which customer we're going for. And that's because if we're designing a power producing product for everybody, we're not producing for anybody specifically, right? So when we decided very early on, we are going to go after AI data centers, there's multiple reasons for that. One, the demand is one of the largest growth we have seen in terms of electricity in the last 70 years. That's great. And also, we didn't want to just build something and say, okay, guys, here we are. we actually went out and spoke to a ton of data center companies and really interviewed and asked and surveyed them as to what exactly is the challenge they're trying to solve, and what kind of product can solve their problem. And there's many answers that we got. One that is particularly beneficial to your question is, what is unique about AI data centers? And I think the answer to that is the at least 99.9% availability, right? That's number one. Number two, they can be co-located to population centers, and not always will have available water around them. So we actually did a lot of studies on what exactly the market is looking for. And as a result, when we took all that information and baked into our product, it does not look like a reactor that is making electricity. It looks like an Aalo pod, as we call it, which has 5 reactors connected to a shared steam header with 3 turbines. That's a very strange configuration if you think about it from a traditional nuclear sense. And the reason why we did it that way is because if a reactor is down for refueling or maintenance, then the others can produce max capacity and always produce the thermal energy that the plant promised to produce. Same thing on the turbine side. If one turbine is down for maintenance, the other 2 turbine is sufficient to make 50 megawatt electric. So there's always N+1 redundancy on all of our major systems. So as a plant as a whole, it can provide 99.9% all the time. So there is something called a product market fit when it comes to nuclear.
Okay, so you're focused on AI data centers and delivering energy that's going to be available the way they need it, which is ultimate availability. If you need to shut a reactor down, shut a turbine down, swap something out, you can do all of that without turning the lights off. The data center keeps on running through that whole thing. What I want to come back to, though, is the simplest level. You guys just did something that a lot of people think was completely impossible, because the prejudice that we have as investors, we're kind of taught to think, okay, nuclear reactors are really cool, but everybody knows they take more than a decade to build one of these things. That's just the way it is. You built your reactor in 40 days. Okay, wait a minute. First of all, we need to clarify. You built a test, you're not powering a city in Idaho with this thing yet, but the reactor you built evidences a chain reaction, which is the main thing that kind of makes a nuclear reactor do what it does. You didn't hook it up to an electric generator yet, but when you do that, which I think you're planning to do very quickly, you're not talking about 10 years. So why is it that for the nuclear industry has been around 75 years?
Yeah.
What happened that you can suddenly build one in a few weeks and it used to take 15 years?
I think the answer comes down to both on the demand and supply, right? On the demand side, all of a sudden what we're seeing today is there's the country on the highest level of the government wants to see this done. We see massive amount of private industry also wanting to see this done. We've seen regulations changing where some of the red tapes are being removed and making it more efficient without sacrificing any kind of a safety pedigree, right? So from a demand perspective, and also public is also very much wanting nuclear to come back in many ways, right? And we're seeing, really, different markets wanting solutions that are 24/7 that nuclear can only provide. So from the demand perspective, that's been very strong. Now, obviously, the supply has to match, right? So before even the executive orders came out, when Matt and I started Aalo, our goal was to, really figure out how do we do things differently. If you look at existing commercial power plants that are running and providing 20% of the electricity in the country, those are all large-scale power plants. They're water-cooled systems, and they've run reliably pretty well, and they run pretty good, close to 95% capacity factor. But then, when we think about okay, what if we want to really change the deployment model, where instead of having a decade of construction to build a gigawatt, what if we could build 1 gigawatt every single year by using factory manufacturing of a decent enough sized reactor? But then the question is every technology ideal for factory mass manufacturing? The answer is no, right? So when we looked into all the various technologies, the one that really stood out to us was a non-pressurized system. Why is that important? Because if you think about nuclear, everything has to be at high pedigree, high quality. And so if you think about any pressurized system, their walls are pretty thick. And for you to make reliable, structure like a reactor vessel, you need something called forging, which, at that size and scale, there's only few places in the world that can do forging, heavy forgings. Very expensive, and it takes a very long time. So we wanted to change that upside down, right? If you want to build hundreds of these a year, we can't rely on forging. And the only way you can get away from that is build a reactor that is non-pressurized. So we ended up, instead of using water or pressurized gas, helium, we used liquid metal sodium. That allows us to have very thin-walled reactors that we can essentially bring in plates, roll it up on plate rollers using standard manufacturing machines, can weld up and finish an entire reactor vessel in a matter of 2 weeks or under, compared to 2 years. So that's the kind of delta that we have been working towards even before the executive orders came out. So when the executive orders did come out, we said, okay, let's prove out the things that really takes long in nuclear. We built our entire reactor building, right? Normally that takes about 2 years or more, or many years. So we built it in 36 days. We built our reactor because we had a factory already operational. We built it in under 4 weeks. And we built 540 fuel rods into fuel bundles in 2.5 days last weekend. So we wanted to really, change the status quo and challenge, bringing in the speed factor into everything that we do.
Okay, you used a couple of phrases in there that I really want to focus on next. You said factory production at one point, and then later you said factory mass production. I think that distinction is super important, because if you look at what some of the SMR developers are doing, the small modular reactor market, things like the Westinghouse AP300 or the GE, BWRX 300, they're talking about building modules in factories. And as far as I can tell, what they mean by that is when you order your AP300 reactor, some of the pieces of that reactor that are going to be custom built just for you will be built in their factory and then shipped to you. But it's not like they're spinning up a factory right now that's making a shelf full of AP300 parts.
Mm-hmm.
Factory mass production is something very different, where you're actually making a lot of something, and you're already building it before the guy has signed up to buy it. When you say mass production, there's only less than 500 nuclear power reactors in service worldwide today. How many more of them is Aalo Atomics planning to make, and in what time frame? What do we mean by mass production?
So it's a good distinction to draw, and I think it's worth highlighting the history here. Probably the best example in the entire world, all time, of factory mass production in nuclear is combustion engineering in Chattanooga from the US in the past 75 years. And they basically made vessels for around 60 plants. They made, in some cases, just a reactor vessel, in other cases, more of the balance of plant. But to your point, it wasn't really true mass production. I mean, they had to locate the factory on a river so they could ship the pressure vessels on rivers, because it was 25 times too heavy to ship on normal roads. And so the whole idea that we're going after here is saying, there's two main ways to make something cheap. You make it much larger, or you make it much more numerous. And nuclear has only ever done the former. We've never made nuclear cheaper by doing the latter, through mass production. And when we say mass production, to your question, we're talking about hundreds or thousands or tens of thousands of these reactors per year, and all the modules that go with those reactors to complete the entire power plant. So the whole idea, our kind of design constraint that Yasir was alluding to earlier, with using liquid metal as the coolant for low pressure vessels, thinner walled vessels, easier to plate roll in your factory, not heavy forged vessels. The whole design goal is, what is the most powerful reactor and plant that you can still fit on the back of a normal truck, under basically 12 to 14 feet, depending on the region, in terms of diameter, to allow you to use not only mass production in the factory, but mass transportability, using the global transportation network to transfer this stuff from your factory all around the country and the world. That really matters when you're talking about 1,000 or 10,000 reactors. It matters less when you're doing one large bespoke project every 10 years. And maybe Yasir would add more to that.
Yeah, and Eric, you actually identify the subtleties on those two phrases, and they do mean different things. And I agree 100% with what Matt just said. So if you think about what Aalo is doing right now, we have a 40,000 square feet in Austin. We can build one, maybe two reactors at a time. That is not mass production. That is factory production, but not factory mass production. So Matt and I have been really working hard, trying to pick the right technology, trying to figure out the right talent to hire, trying to figure out like where can we learn from outside of nuclear to really figure out what mass production really means and what it takes to deploy, right? So right now, our factory does not have an assembly line, as we call it, right? The next phase of our expansion is planning exactly that, where we're planning to expand maybe 10x over the next year or two to 400,000 square feet or so of a facility. And then after like 2 or 3 years, we'll expand that another 10 times. And the whole idea there is two things. One, we want to actually build the first nuclear assembly line where you have jigs and equipment and processes where material flows through, and then you can make the same modules over and over and over again. And the way that you set up the factory is in terms of like a honeycomb, cells. Like each honeycomb or each cell of a honeycomb essentially is geared towards having an assembly line to build a particular module of the plant, so we can do it over and over again. We currently don't have that, but we're working towards building one, right? That's number one. Number two is vertical integration. A lot of folks underestimate the level of effort needed to build majority of the hardware in the factory, right? Right now, we're not making everything. We have a very healthy supply chain, and our whole mission was like, hey, we want to make sure that whatever we design in our reactor, nothing should be what we call an unobtainium. So either we are able to make them ourselves in Aalo's factory, or we can essentially buy it from our reliable suppliers for like a pump or a turbine or a sensor or electronic cabinets, for example. So ultimately, when we hit the barriers of scaling for either price or quantity, then we would want to take control of some of the supply chain and build it ourselves. And the more we build ourselves, the more we'll have control over the overall ecosystem. Now, having said that, we still need to rely on suppliers and vendors for raw materials, for sensors, for smaller components. But that's something we'll need to get more and more into, is like, how do we make more components more in-house and complement what the industry can provide today? So that's the true distinction. There's a lot of challenges we have to solve before we move from factory production to factory mass production.
Okay, so you said that right now you've got a 40,000 square foot facility in Austin where you've built one reactor that you already fired up on Saturday. I know you're working on building the next reactor in that existing factory, but I also know you guys are shopping your Series C term sheet right now. The purpose of that fundraising, as I understand it, is to build the first mass production factory. So is that correct? And if so, once you've built it with the money that you'll raise in your Series C, you go from being able to build 2 reactors to building how many reactors, let's say, per year in this new facility that you're going to build?
Yeah, that's right. So far in the company history, we've raised around 300 million. We've spent under 100 million. So we still have 200 in the bank. That is largely going towards your earlier question of going from the 0 power criticality that we've achieved as of Saturday early morning, Friday night, taking it to a full power operation with a data center right there on site. So there's a bunch more work to build that out and operate it that we're going to do in the next few months. But to your point, we're not resting on our laurels. We think we're onto something pretty special here. So we are raising a 500 million Series C. We are getting pretty close. We had a lead term sheet verbal offer recently, and there's a bunch of good leads leaning in. And so that's the stage that we're at, where I think now that we're post criticality, we'll be getting to term sheet stage pretty soon. And to your question, the use of those funds is really two main things. One is, as Yasir mentioned, building out the 400,000 initial phase of this kind of next million square foot factory. So we're starting with this 400,000 square foot space to 10x our current floor space and start to build out the Aalo pod, which is again 5 reactors and 3 turbines for high availability through fleet redundancy. And so we're building that product at this new factory and basically starting in August, in the next month or two. And we'll be building out that factory largely in 27, starting production then. And that brings me to the second use of funds largely for the Series C, which is some of the project equity portion of the first few commercial pods. So those commercial pods are going to be financed partially with debt, partially with tax equity. And obviously, for first of a kind commercial technology, it's going to be a little bit more equity heavy as we de-risk the tech and get more towards debt financing. And so those are primarily the usage of those funds. Maybe Yasir would add more color on how we'll build the factory and how many reactors we're looking to do per year and by when.
Yeah, and Eric, to answer that part of the question, so there's a fallacy that building too much automation up front or building up too large of a capability before even knowing what your standard product looks like, it's difficult to really establish an entire, let's say, factory that can make hundreds of reactors without getting to that standard design. So we want to be very methodical about our expansion in our factory. So what we're doing is breaking that down into 3 phases. Phase 1 is we're not thinking about how many are we going to produce. We're saying, hey, we're going to expand from 40,000 to 10x, 400,000 square foot facility, and then figure out what is our product we're going to be building, how are we going to build it, establish the first assembly line for nuclear, really build the jigs to make it over and over again. We're not thinking about how many numbers we have to hit initially. First, we'll be establishing the nuclear assembly line. The second phase, once we accomplish that, is maximizing vertical integration. There are things that we want to build that we're not building today. We want to make sure our factory space can accommodate that. So from 400,000 square feet to something larger, maybe 5 to 10x of that space, we're going to make sure we get all of that vertical integration wishes come true over the next few years. And then the last phase would be, okay, now from here, now we know our product, what exactly we're building. Now we know the fraction of the components we want to build ourselves and the rest we want to buy from others. And we've got a supply chain built up. Now let's go build and make sure we expand however much square feet we need based on our learnings to build at least 100 reactors a year, right? It could be, at least 100. It could be 200 or 300, but we want to make sure at least a gigawatt every single year from this first factory.
Okay, I want to distinguish also between we've talked about factory production and factory mass production. Now let's distinguish mass production of reactors versus mass production of entire power plants, because I think what you intend with the Aalo pod is not really mass production of reactors, but building the whole power plant. So everything you need to hook your data center up to is all factory. Basically, it comes from the factory. You deliver it on site, set it up like IKEA furniture, and you've got a power plant. Is that the vision?
That is the vision. Go ahead, Matt. It's your turn.
Oh, no. Well, I feel like this will be a quick one, but yes, that is essentially the vision. And maybe what I'll highlight here is Yasir already kind of touched on this. Yasir has a great phrase. We like to make sure we don't choose any unobtainium in our reactor design. And so we put a lot of thought towards how do we scale from 1 reactor per year, where we're at today, to 10, to 100, to 1,000, to 10,000 reactors per year. And we have this kind of internal document showing the entire BOM, the bill of materials for the whole factory, and which parts of the supply chain will bend or break as we scale up that logarithmic curve. And so we put a lot of thought towards this, and we kind of have an understanding, especially given that we've now built and turned on a reactor, based on real experience with the supply chain, where certain things, for example, it's easy to buy graphite, but we can't easily have people machine it. So we have to machine it ourselves. PCHEs and pumps might be some of the next things we do ourselves, turbines soon thereafter. But we never vertically integrate just for fun. It's when things are too slow, too low volume, or too expensive. And that's really a big part of our strategy to say, nothing from first principles precludes you from creating a factory that can produce 1,000 or 10,000 reactors a year. In fact, oil and gas has deployed at 100 gigawatts per year in the past. Why not nuclear? There's no reason nuclear can't do that as well. And the way you have to do that is you have to set up a factory that can do as much as you need to do yourself in order to achieve that scale where the supply chain can't support you. And that's exactly what we're going to do.
Okay, so July 4th, 26, you did your first test reactor, just evidences criticality. You got the sustained nuclear chain reaction. Sometime in the second half of 27, you're planning to deliver the first commercial reactor that actually makes electricity that you could sell to somebody, that goes into real production, runs a real data center. How long after that, or in what time frame? Let's suppose somebody watching this podcast right now is a data center guy that calls you up and says, I want to order the first Aalo pod, this factory built, complete, ready to go power plant that includes 5 reactors, 3 turbines, and all the equipment to run it. Give me a delivery date. I'm ready to sign up today. When can I have it?
Well, they can sign up now if they want to.
Click on the bottom of your screen.
Click here to buy. No, in all seriousness, I think, we want to go and tackle and get to maturation in a methodical way, right? So up until the critical test reactor, we have been running, sodium scale tests on majority of our components that have to essentially be the main functional components, like a pump or a printed circuit heat exchanger or a cold trap that purifies sodium, or steam to sodium, sodium to steam, double duplex tube heat exchangers. There's a lot of different technologies you have to work on to make sure you can bring this plant to life. Now, we've been doing a lot of the smaller scale tests in the past, in laboratory scale and in engineering scale. The missing piece was we did not know what our nuclear behavior of our technology would look like. And hence, we built the critical test reactor. And we didn't just build it just to go critical and hit the July 4th milestone. We wanted to make sure it made sense from a data collection and physics perspective. It makes sense for the commercial reactor. So we built everything at full scale. The fuel, the moderator, the control system, everything was built at full scale. And so taking all that learning, we're going to next move to the power production phase. So for the next reactor we're building next door, as you mentioned, Eric, we are planning to finish the construction end of this year, and sometime maybe before July 4th of next year, we will make 10 megawatt electricity and maybe hook up a small data center to see how the harmonics from a co-located nuclear and AI data centers work out from a control and electrical distribution perspective. That is something that I think we need to get better at, right? And then that first reactor will also be built in our factory, not just for factory production, but for factory mass production. We would actually build an assembly line to make AaloX, and before we can standardize that hardware. So to answer your question, it depends on how aggressively we can find our first customer to deploy with. And we're talking to a lot of different AI data center companies. They've been waiting for some of these milestones to be hit on the technology side. But I think as soon as our team manufactures the modules for AaloX, or end of this year or earlier of next year at the latest, they can immediately start thinking about the pod. How do we build the first commercial system? And so when can you have one? I mean, I'm probably going to get my hand slapped by my CFO outside of Aalo, we have a COD by 2029. But Matt and I we like to do things faster than what we always tell people. So most likely it's going to be significantly sooner than that, when we can actually not only deliver the system, but we will have an operational machine before 2029, right? I want to come back to your previous question, Eric. Is like, when you think about nuclear, it's never an ideally a project the way we think about today, or an ideal product. It's always a grayscale in between, right? No matter how much you try to make a product out of nuclear, you have to go to a site, and you have to do some earthwork, you have to do some infrastructure, you have to do interconnection of electrical machines and cables and switch yard. There is some construction effort needed. So when we think about mass produced reactors in a factory, it's not just like, hey, we're going to build 100 reactors a year or more and call it good. You have to think about the entire deployment speed as a whole. We have to make sure we can do project development faster. We can make sure that on-site construction is done in a reasonable amount of time. You have to make sure that we can build stuff in a factory. We can license those reactors to the NRC at a reasonable time frame. We can go through the initial startup commissioning and testing and hand over the operations to a customer or ourselves if you want to operate it. All of these things, from project development to turning on the machine and producing electrons, have to be done in a shorter time frame. So when Aalo is thinking about like factory mass production, it's not just the factory sliver, it's the entire stack of delivery. So our goal internally is, it's not just about the factory, it's about from an order, when some customer says, hey, I want an Aalo pod, from the order to electrons, we want to make sure that for nth of a kind, we can deliver that from order to electrons under less than 6 months.
6 months. Okay, this takes me to my next question, which is what I call the lightwater leapfrog. What I mean by that is, I think investors have it just baked into our heads that the way this whole nuclear landscape looks is you've got generation 3, or now generation 3 plus. The lightwater reactors are based on technology originally developed in the 1950s. That's what we've got now. And then this advanced stuff is coming someday, I don't know, 10 years out, something like that. We're going to have advanced stuff. Well, wait a minute. If you think about how long it takes to build a new AP1000 plant, like the Vodal plant was the last one constructed in the United States, took 15 years or something to finish that thing. So if
18.
you were to, okay, so if you were to, well, and there, I think, well, there are very smart people that are working really hard to reduce that time. One of them, our mutual friend, Mark Nelson, happens to be an investor in Aalo because he also sees the future. There's lots of people that are working to bring that in. Let's say they got it down to 10 years, really much faster than it's been in the past. Okay, nobody's building one yet. So the earliest they could possibly start is, let's say, September of 2026. Wait a minute. That means the first power comes at least in no earlier than September of 2036. It sounds like you guys are selling commercial electricity starting from maybe 2029. So who's actually first to deliver new electrons? You're going to cost more, at least in the beginning. But by the time we get to 2036, which is when that AP1000 that gets, green lighted tomorrow is actually going to go live, ambitiously, that's 10 years instead of 18 it took for Vodal. Will you be selling Aalo pods by 2036 that bring the cost down to the point where it's competitive with those AP1000s? And if so, who's first to market with the competitively priced electrons? Because I see, and I don't necessarily know that your company, Aalo, is going to be the one to do it, but my expectation here is generation 4 advanced nuclear is going to just suddenly happen, and it's going to happen faster than the industry is used to, and there will be a bunch of in-process, bigger, clunkier, old school reactors, and you guys will suddenly be at market faster. And for anybody who's willing to pay a little more, they're going to want to use the generation 4 stuff. Does that create am I right to think that's possible? And if so, what are the implications?
Yeah, I think you're spot on there. And our view is, if you look at where the demand is coming from, it's largely coming from these AI data centers. And there will still be a few AP1000s built. These are good for these kind of bespoke, large utility projects. And I think we'll see a few more of those now that nuclear has been legalized again in the past 5 years to be built. But our whole thesis is we are really building the ideal product market fit for AI data centers. And we've already talked a lot about the factory mass manufacturability, the mass transportability, the supply chain ability to scale. And really, if you look at how we're powering data centers today, it is not with gigawatt scale, nuclear plants or things like that. It is actually with 15 to 60 megawatt gas turbines. That's how largely the OpenAI Oracle Abilene project is being powered. It's largely how XAI in Memphis was being powered. So we're essentially making the nuclear version of that. And the reason it's advantageous is because you don't need some labyrinth of underground pipeline as you do with natural gas, which kind of constrains where you can put it. And you don't need to use anything like magma pocket or fast moving water. We actually don't use water at all, which is also good, even though that's a bit of a overblown narrative for data centers, but it's still an advantage that we don't use water. And we use 100 times less land than renewables. So it's really a great nuclear solution, a great solution in general for data centers. And the whole idea here is as we come down the cost curve, starting at 15 cents around there, getting down below 10, it'll open up a whole plethora of other markets we can go after, almost in a similar way to how Amazon started with books. That was just their wedge market. But then eventually they went after all sorts of other things and they became the everything store. So we think we can do something similar in energy. And to your point, the goal is to one day be deploying much faster on a even kind of gigawatt scale than if you were to build AP1000. So in other words, you could build a fleet of smaller reactors and get to many gigawatts per year, maybe 10, 20, 50 gigawatts per year or more, way kind of more reliably and predictably with this model than the gigawatt scale AP1000 model. And this is a contrarian view. I mean, not everyone in nuclear believes this. There's a lot of nuclear historians who are very knowledgeable about the past, but the reality is the past does not always look like the future. And we are, essentially all who exist to create that future where nuclear is faster and more predictable to deploy.
Yeah. My view on this, if I want to add to what Matt just said, is we actually need as many nuclear solutions and as fast as we can, regardless of its size, quantity, type of technologies. So we do, as really proponents of nuclear, Matt and I, we both want almost every nuclear technology, we want them to come to fruition. But the market is very large, right? But there is no silver bullet, Eric, right? The reason I say this is because if you think about AP1000 or any of the large-scale existing water-cooled reactors, they do take a long time to build, and they'll get better at it. Maybe they'll get 10 years, or maybe if nth of a kind, 6 or 7, perhaps. That's great. We want to see more of these large-scale plants to come online. However, as you mentioned, I think speed is the name of the game that we're seeing. The customers are actually willing to pay more for deployment faster. Some of these data centers are getting built in 2 to 3 years per campuses, and they're not going to wait a decade or 8 to 10 years to find power for that, right? So we're seeing more than the cost necessarily. We're going to see that speed is becoming more and more important to some of these systems, and the downside that that we have to face, and the battle that we have to overcome, is our systems don't have as much operational experience compared to some of the large-scale water-cooled plants that have been running for 7 decades, right? So their capacity factor is as good as it can get today. Most likely, we're not going to start at 95% capacity factor. And that's okay. We bake that assumption into our cost models. Maybe initially will be, I'm just going to wildly swag this, even though we're designing this to be 95% plus capacity factor. Let's just say in practice, in operation, it ends up being 60 to 80%, somewhere over there, right? We understand that over time, we're going to learn more from operations and improve. Let's say we're going to see some components needing maintenance or repair faster than what we have predicted, and that's okay. That's the benefit of going to this pod arrangement where for the first time we are untethering capacity factor, which is like how much time a nuclear reactor is on, with the overall output or availability of the overall plant, because we have multiple reactors and multiple turbines. So yes, initially, if they want to deploy, AP1000s or gigawatt scale reactors, we'll have to wait many, many years to get there. But they have that certainty of they know what they're going to hit on the capacity factor. They know how they're going to operate some of these reactors. Whereas for us, we'll have to learn and demonstrate those things in our operations and as we deploy more. But Matt and I are overly, we are optimists. We feel very strongly in the direction that we're going. And we feel like by the time the first AP1000 is built and making electrons, we would have come down that cost curve by deploying multiple systems and be able to get that operational data to know exactly what our capacity factor looks like. We'll know exactly what the prediction is for our cost and deployment times look like. And we're going to do everything we can to make sure we're competitive, not with large-scale power plants for nuclear, but be competitive with gas turbines, because that ultimately that's our main competitor in the market, is be better compared to gas turbines.
I think you just said the most important thing of this entire discussion so far, at least in my opinion, which is the holy grail of nuclear is the day that we can make it cost less than energy from coal and gas. Because the instant that you do that, it unleashes what I call the nuclear Henry Ford moment. All of a sudden, you bring it down. What Henry Ford did with the automobile, which was something that only the filthy rich could afford, is he brought the cost down to the point the common man could afford one. And that completely changed the world that we live in. So let's just sort of think about different timeframes. In 2029, when you sell your first commercial Aalo pod system, it's going to cost a lot more per kilowatt hour than you're going to get from a coal-fired power plant, by a lot. And really, it's only going to make economic sense to data centers that can afford to pay up for that additional cost. But let's now step out to 2036, 10 years from now, which is how long we think it would take if you started a new AP1000 project tomorrow. That's how long it would take before it comes online. If I go 6 months before that and I call you guys and say, okay, 6-month lead time, I want to order an Aalo pod, what do you think the cost is at that point? Is it, I'm guessing 10 years from now, it still probably costs a bit more than the coal and gas plant does. Does it cost more than the AP1000? Or what do you think? Is it, what time frame do you get to where?
So our company mission is to one day achieve 3 cents per kilowatt hour electricity. Now, we're not kind of crackpots thinking we're going to get there on our first of a kind reactor or a second of a kind reactor. This is kind of much more the long-term mission of the company, in a similar sense to SpaceX trying to make a fully and rapidly reusable rocket. SpaceX has been around for 25 years and they're only just about to achieve that goal. It'll probably take us maybe the same, something similar, 20, 25 years to get to 3 cents. But we do have a pretty clear pathway to get certainly below 10, and getting from 10 to 3 will involve different types of creative innovations, and we'll speak a bit to that. So, first of all, I want to say right now our modeling is based on having built a real reactor. So again, 2.5 years ago, we were 2 people. Now we're 200. We've raised 300 million. We've built a reactor and turned it on. And it's a 30 megawatt thermal, 10 megawatt electric, kind of equivalent sized reactor. It doesn't have a sodium coolant loop yet, so it's a 0 power criticality. But in the next coming months, we're going to bring it to full power. So we're not kind of doing finger in the wind economics. We know a lot about this system. And really, like Yasir said, the capacity factor is the main thing that we're going to be adding to the model in the near future. A lot of our finance team, I believe Yasir also referenced this, came from Bloom Energy. They've been on a real tear recently. And so our CFO was the former global head of structured finance there, helped them go public, raise 5 billion to finance all their infrastructure. So our team really knows, economics of kind of on-site industrial loads. This is their bread and butter, and it's largely going to be our market for the coming kind of 5 or 10 years. So to get from 15 cents, which I've just kind of laid the landscape on why we think that's an accurate estimate, down to 7 cents, there's a lot of pretty basic things around vertical integration, building this first factory out, going from 1 to 10 to 100 reactors per year, probably a couple hundred reactors a year by, you said, a few months before 2036. So I think we are at that point going to be somewhere between 7 and 10 cents per kilowatt hour. And that is really already a holy grail energy product. A paid off AP1000, after it's all paid off, is producing around 2 or 3 cents a kilowatt hour. And then, earlier in its life, it's maybe closer to that 6, 7 mark. And so, but the thing is, you've never had a nuclear product that can produce electricity at that price. And when you have a smaller nuclear product that can do that, you can do a lot of large kind of on-site industrial loads and save a lot of money on transmission. So people don't realize transmission is half the cost of delivered electricity. So if you have like certain things like desalination, industrial process heat, data centers, and you power them on site, you'll save cost through having less transmission. And we're also going to solve this problem where data centers are facing a lot of NIMBYism because they're actually increasing power prices because they're straining the grid. When you do on-site power generation, you're not going to be straining the grid. And anyway, we could talk on that for a long time. I know we're getting short on time. The last thing there is just when you go from 7 cents down to 3, that would involve a lot of innovation around regulatory, permitting, siting, automation, and construction. It might require a shift like we've seen in airplane turbines and going from scheduled maintenance to just-in-time maintenance. It might involve things like having centralized operations of thousands of reactors around the country instead of having 20 staff at every single reactor kind of thing. So there's lots of different things you can do to innovate to get down to 3. And we actually publicly posted a kind of a economic model on this topic for people to play with, so we can have more granular debate on this topic and not just have hearsay, theories thrown out just like some kind of weird, vague slam battle on Twitter or something. So we've done a lot of thinking on that if people want to dive in. But that's probably the short version of the answer. We could probably do a whole hour podcast on this topic.
Yeah, I do want to add a little bit on the data analytics side of things to complement everything that Matt has just said. And so if you think about what learning curve really is, right? It's like, hey, if I double the volume of what I'm making, how much cost reduction am I going to get? And that's the benefit of building a product that can be done in a significantly short amount of time. Let's say for AP1000, for them to really learn and double after the first one to take on the learning to the next one, it might take a decade and a half or 2, right? Whereas we can learn significantly faster from that learning curve. And so just to give you an idea, the faster we can learn, the faster we can come down that cost curve. A keen example from the recent, building the CTR was, we were debating, Matt and I, like, hey, should we build a reactor and stick it into an existing DOE facility, or should we try construction? And so both of us, we said, no, let's try it. And the interesting learning from just one project alone was that we had a cost estimate for our full powered Aalo X reactor, the full 30 megawatt thermal that we're already building right now. And I'm not going to say the exact numbers, but let's just say it's $100 million for the construction cost. When we did CTR, we took a slightly different approach in constructing the reactor building in a way where we moved all of the safety functions from the building down to the equipment. If we follow that same philosophy and we applied that into Aalo X, what we learned was that the construction cost, and this is based on actual quotes, by the way, What previously costed us, let's say, hypothetically speaking, $100 million, now all of a sudden it's less than 20 million. So just by taking that learning that we had from building the CTR building, we were able to reduce the construction cost and time by 5x for our full powered reactor. Had we not done the CTR construction building, we would not have had that insight in literally cutting down the cost by 1/5. So that's the kind of learning that we are expecting to see over the next few deployments, faster than some of the larger scale system that takes longer. And I do believe firmly that very soon, we are going to hit a price point that is going to become very, very compelling.
I think you will too, and I think that's the moment that you guys or your competitors will see how this works out. But I think the nuclear industry will change the course of human history when we can figure out how to deliver nuclear for less than the cost of coal and gas, because that's the point where demand becomes unlimited. The international willpower to replace coal and gas with something better is so strong that as soon as you can bring the cost down and make it affordable, I think it changes the course of history. Before we close, I do want to touch on the fuel choice that you guys made, because this is so important. And the analogy I like to use is, imagine I told you I've got the coolest sports car ever. This thing is so cool, it uses a special new kind of fuel that they don't even have at the gas stations yet. Oh, wait a minute. That means, how am I going to drive it? Because there's no way to fuel it up. Tell me how that analogy applies in the nuclear world, Yasir, and what decision did you guys make, and what do you plan longer term?
No, again, no fuel, no reactor, and when every single decision we have made in Aalo in terms of the technology choice or the market or the particular component or part, it was really, we always prompt ourselves: is it going to make it faster or cheaper? And when we asked that same question for fuel, we really hit a barrier initially. When we started Aalo, we were not using UO2, low enriched uranium. We were using uranium zirconium hydride. That is a very kind of an exotic fuel type that only one company can build in the world in small quantities. So for us to really get to market fast and be able to deploy, we found ourselves in a tough spot that, hey, we picked a fuel based on its properties, but we don't have a supply chain. The cost is high, and we can't even make, beyond our first reactor if we get lucky. So when we think about every single component in our reactor, it's never about how do we build this one-off reactor system, or how do we build off, one core. We're thinking about how do we build the next 100. And so what we have done essentially is this: like, we have built an advanced reactor using commercially available uranium dioxide fuel, and not only that, it's low enriched uranium. We are not counting on HALEU to get to market. Now, when HALEU gets unlocked in the future, when the price can come down and economics make sense, we can absolutely switch to HALEU. But in the near term, our economics and performance does not rely on HALEU to be available to us, right? And that's a huge distinction, Erik, because if you think about deployment and really what the market is looking for, we need a solution that we can scale up to hundreds of these systems without hitting an obvious bottleneck. And from where I see the trajectory of nuclear fuel, I think some of these newer fuel form which have gone through qualification, or which have but we don't make them in large quantities. It's going to take a couple of years before we get there. So Aalo has this leg up in terms of this fuel availability, that we can build an advanced reactor without going to a new fuel form that does not have operational data as much as UO2 does. We have 70 years worth of data from this fuel. The regulator is extremely familiar with this fuel. We know the prices, we know who makes them, we know how to transport these, we know how to make pins out of it. One thing we don't know is the fuel bundle that is unique to Aalo. And we just demonstrated a semi-autonomous machine that can make these fuel rods into fuel assemblies and do that over and over again. And we demonstrated that in our July 4th goal. And that's the kind of thing that can really set us apart in terms of deployment is we don't care about one reactor. We care about how do we deploy the next 100.
One of the things that surprised me talking to some of your team members is I thought the technology would be the gating factor. You know, you'd have some challenge, we can't figure out this or we can't figure out that. What I hear from people inside your company is actually the challenge is growing the team. It's finding the right people to join this extremely fast-moving culture that you have. And it happens to be near and dear to my heart because I have a family member who works for you. She almost chickened out of sending you a resume because she said, these guys are too cool for school. The stuff they're doing is so awesome. There's no way they're going to hire anybody who doesn't have a PhD in nuclear science and engineering from MIT. Anything less, they'd probably never be interested. What she tells me now is actually it's not even nuclear science and engineering degree holders that you need the most. So what is it that it's going to take to build this company to really do all the things that you're talking about? And for our listeners who might want to work for you, I know you're hiring aggressively. What's it like to work there?
Well, we're expanding the team from around 200 today to probably 300 or 400 in the next year or two. So we do need a lot of people to join us. And we've been really blessed with hiring an incredible team. So, you know, from the leadership all throughout the company, you know, we've got people who worked at a lot of Elon's companies at SpaceX and Tesla. We have the former head of manufacturing from SpaceX until they landed the first rocket. We have the individual who actually led the Tesla Cybercab program, those golden self-driving taxis. The leader of that whole program has joined us. And we have people who led finance at Bloom, like we talked about, people who've been directors at Microsoft and Google. So, and the people kind of with deep, you know, one person has 50 years of nuclear experience. I'm not even sure how that's possible, but it's true. So we've got a pretty deep bench, and yet we're looking to add people constantly. So people don't have to have, to your point, Eric, MIT nuclear physics degrees, although some of our folks do. But it's going to be, you know, people that are experienced at welding, people that are just bright optimists who are hardworking. That's the kind of people who are problem solvers and who love working on really ambitious challenges with really smart people. That's the kind of profile we're looking for. So, you know, we definitely would encourage people to go to our careers page on aalo.com, aalo.com. And obviously, if anyone here wants to invest, please email me, and I'll route your request there as well. I'm not sure if I'm allowed to make this plug, but anyway, it's too late now. So
yeah, and Eric, you know, I want to again, you know, you're absolutely correct. What is most important to us more than anything, we're always facing new challenges as we progress as a company. So when we hire people, it's not the shiniest resume that can essentially make it across the finish line. It is attracting people who are extremely good at problem solving. That's number one. We create a culture where problem solvers can truly thrive. Doesn't matter what position they have in the company. If they can solve a problem, we give them that responsibility and we give them that ownership. So that extreme ownership coupled with, you know, problem solving is really the secret sauce. And you give them a mission that is larger than life. That's the ideal mixture of creating a culture that is self-sustaining. And not only that, we don't tell our team exactly what to do, when to do all the time. We give them enough autonomy so that they can bring their creativity, they can bring their innovative minds to solve their problems on their own. Like most of the brightest ideas did not come from Matt and I. Most of the brightest ideas came from our team members who really are bringing that diversity in mindset and talent and knowledge base. And so we really create that environment where they can really, you know, become their very best. And so we want to maintain that culture no matter how big we get as a company. So Matt and I always promise, like, hey, let's hire the best in the world, not make sure that we never compromise on that culture, and always keep that high bar so that we have an A+ team all the time. And so even if we hire somebody subpar, they become part of that ecosystem and really bring their very best when they come to work. So, yeah.
From everything I hear, it sounds like an amazing place to work and just a super high energy culture. So it's very exciting what you guys are doing. I want to close by sharing with our audience what's coming next. Yasir, you're not off the hook yet. We're going to draft you for a few return visits. We're launching what we're calling the Nuclear Chief Technology Officer, CTO series, where we're going to get Yasir and other CTOs from advanced nuclear companies. We're going to take this stuff. When somebody says, well, Aalo is making a sodium cooled thermal spectrum, whatever the heck that means, uranium oxide fueled reactor, but this other company is making a triso fueled gas cooled reactor. It actually matters to understand those distinctions. So, what we're going to do is get the CTOs that made the decision to choose a particular coolant or a particular fuel or a particular reactor design, and they're going to slug it out and talk about why they made those choices and what the benefits are of them, so that we'll use that as essentially a vehicle to teach investors about nuclear technology, how it works, and what they need to know in order to invest in it. So follow Zero Hedge Debates. That's coming up here on Zero Hedge. I also wrote a pretty detailed Substack about this criticality event that was so exciting to watch. I watched the live stream this weekend, the 3rd of July, Friday night, into early Saturday morning when the criticality happened. You can watch that replay as well. You find that on X. Is that on the Aalo website as well? And of course, you guys are at aalo.com, AALL.com. Anything that either of you want to add before we close? And Matt, you didn't say it, but I'll say you've got an open funding round right now before Series C even gets priced. So for any accredited investors who are able to invest in private equity, Matt, or do you want to give Hill's contact, or who should they contact if they want to find out more about investing in the company?
Yeah, so definitely reach out to me, and I might connect you to Hill depending on check size. But we do have the safe note open right now, and like I said, the window is closing because we're getting verbal term sheets after criticality, and I think we'll probably be signing a Series C term sheet, which will close up the safe, and then we'll be closing the C with larger other checks. Probably announce me this maybe in August. But yeah, please email me, matt@aalo.com. matt@aalo.com, and we'd love to explore partnership with anyone online who's listening and interested, who's accredited, like Erik said. And otherwise, really appreciate everyone's time and attention. It's been a blast for Yasir and I to build this company, and we can't wait to keep pushing as hard as we can to make this, change the face of energy on Earth.
Super exciting, guys. I'm sorry, did I cut you off, Yasir? Do you want to say something else?
No, Matt said it perfectly, and I'm looking forward to being part of the CTO debate series, Erik. I'll promise I'll be friendly. I think it will be very educational for a lot of us, and in fact, I'm going to learn something too from other CTOs. They're extremely bright people, smart people, and we can always learn from each other. And I think the more we can have this open dialogue, open conversation, the more we can make nuclear better and better. So I'm really looking forward to that. So thank you for having us here.
I'm convinced you and the other companies in your same advanced nuclear space are going to change the course of history. It's all about that day where you get the cost down to less than coal and gas. I know that's a few years off, but it will be I think, a bigger change than the Industrial Revolution when it happens. So I'm very excited to watch it. That's a wrap for Zero Hedge. I'm Erik Townsend. Be sure to tune back in for our Nuclear CTO series. Check out my Substack, and definitely check out the replay of the criticality event. This was a really important breakthrough that you guys made.
Amazing. Thanks for having us.
Awesome. Thanks so much.